Hey, what's up, folks? Welcome to another 3D Hangouts. My name is Noah Ruiz. I'm a designer here at Adafruit, and join me every week is my brother Pedro. Hello.
Good morning, everybody. I'm Pedro. It's great to talk here at Adafruit, and every week we're here to share 3D projects featuring electronics on Adafruit.
That's right. This is the show where we whoa. This is the show where we combined 3D printing and DIY electronics to make inspirational projects. Hello, everybody. Welcome to the show. We're all Festivus over here. It is episode 464. It is December 11th, 2024. And we're hanging out. We got a new project that is in moderation. It's about to get published. We got new 3D printed time-lapse. We have shop talk. We have some photos from an event that I attended on Friday. SLA prints that are on order that we're going to stock in the Adafruit shop. So much stuff going on. We got a coupon code that we'll share in a little bit, and we're just excited to see everybody. We have one more show next week, and then the week after, we're off for the next 2 weeks and into the new year.
Whoa.
What an exciting year. It's already over.
I thought it was in 2 more weeks or something.
Yeah.
Yep. Oh, wow. Even the video after this is just like the countdown of all the projects for this year.
Yeah, like a yearly roundup video we'll probably do of all the projects that we've done this year. So we're hanging out in the Adafruit Discord server. If you'd like to join us in the community, discord.gg/Adafruit is the link. Hanging out in the live broadcast chat channel are a couple folks. Give some shout outs to Do Wester, Paul Cutler, and Squid.jpg. Hello. Thank you for joining us during the live show. And everyone else who's watching us later. Hello. This is 3D Hangouts. We have a new banner here. We've got rid of the old printer. We put the new printer.
We like it so much.
Yeah, we put it in the cover.
I forgot to take a photo with the
Adabot. Well, at some point we'll do one with an Adabot. I'd love to redo Adabot with like more colors, since now we have the capability to just kind of do multicolor individual parts as a part of the bigger assembly. So that's going to be fun. I got to do that. I still got to do my owl in multicolors. Yeah, so why don't we just go ahead and go to adafruit.com/free, find out all the deals. These have been ongoing. We've been able to keep supplies in stock, so that's really nice. So for folks that are ordering anything that's on $99 or more, you can get a free PCB coaster with the gold Adafruit logo. For orders that are $149 or more, you get the PCB coaster plus an Adafruit KB2040, the lovely RP2040 based dev board in a Arduino micro form factor. And if your order is $199 or more, you'll get the KB2040, the PCB coaster, and free UPS ground shipping for Continental US only. And at the top tier, you get a free Circuits Playground Express if your order is $299 or more, plus the free shipping, the KB2040, and the PCB coaster. Adafruit.com/free for all those details. They get automatically added to your cart. And then while you're at your checkout, why don't you use our 10% off discount code DotStar, DOTSTAR, DotStar will get you 10% off your order for all the things that are in stock, which we've got a lot of things in stock, which is a good thing. So that is my spiel. Adafruit.com/free. The last thing I want to talk about is holiday shipping. There's a big banner, red strip, danger across the top of the website. It's just letting you know, due to high demand, USPS delivers me, not ship, for the next 3 to 4 days. Of course, it's the holidays. So this will just give you the holiday shopping deadline for 2024. Domestic orders, all the different carriers here, from UPS Ground to International DHL Express. So check this out. If you are looking to get your stuff in time, you can use this site as a reference, adafruit.com/holiday with a capital H. I think there's also a blog post here, right here on the homepage of the blog. You can see that. It gets updated, I think, right? Every time we advance a week. So yeah, just gives you an idea of when you get your order. If you use a 3-day select UPS versus a 2-day versus the next day air. So yeah, check those out. Adafruit holiday shipping 2024. That is important to note. All right. here we are. We really ran through that one. So this week's project, it's a learn guide. It's in moderation. We're waiting for Lamore to take a look at it. I'll share about it. I think I could probably walk through the guide a little bit and then do a demo. So we've probably seen me talk about it for the past month now. It is a persistence of vision, or POV LED display. We have 2 LED strips here on these 2 arms. We have a yellow motor here. It's often referred to as a TT motor. Just a nice 6-volt motor. We have some 3D printed gears. We have this open frame so that it's completely modular and accessible. Powering the whole project is a Feather RP2040 right here on a doubler, along with the motor FeatherWing that allows you to do stepper motors, 2 stepper motors, and 4 DC motors, which is a little overkill for this project, but it just makes connecting everything super easy. The motor just connects to a screw block terminal, and then you provide some external 12-volt power to the Feather wing, and you can start making some fun images. So this is all done in CircuitPython. Let me turn it on so you can get an idea. You got the LEDs that are blinking. It converts a digital map image into these blinking lights so that when you are speeding fast, you get some icons here. So let's see what we got. Can you make me bigger?
Oh, what the?
Doing? Love.
There you go.
So you can customize the image. You can customize the brightness. You can even customize the length of the LEDs if you want. But our 3D printed parts house a 32 pixel tall LED strip. And yeah, that's kind of the main thing of the project. Let's see if I can turn it on without. I just gotta make sure it doesn't like clip anything. So let's see it in the background there. So it just keeps spinning along at full speed, and it displays bitmap images that are 32 by 96 pixels, which you can do. So you can have a nice kind of long image, full color bitmap image. It's a little loud because it's a motor. But some of the interesting things that I learned about this project is creating a custom 3D printed ball bearing using steel balls. So they're 5mm balls inside this kind of a sandwich of these 2 hubs. And then on the outside of it are these helical gears. So they just mesh together nicely. And the thing that allows the wires not to get tangled is this slip ring, which is this metal wire harness inside the center here that has 6 wires. So that's how I'm able to distribute clock, data, power, and ground signals to these LEDs. These are DotStar LEDs, hence the coupon code. So you need 2 data wires, clock and data, and those connect to the slip ring on the top here, which it can freely spin. And then I'm using these Pico Blade 4-pin cables that allow me to disconnect these, because otherwise it'd be a little bit difficult to have them soldered. So you can completely disassemble it. And there's just a bunch of screws to attach these arms to the hub. And yeah, that's pretty much the gist of it. Slip ring. This is my first time using a slip ring. This is a perfect application for a slip ring, allowing you to rotate wires 360 degrees without having to worry about them being tangled. And then the other bottom of the slip ring has the wires that are soldered to the doubler, so I can disconnect the feather and the motor wing, use them in another project if I need to. Very, very modular, and everything's like an open kind of enclosure. There's just these 2 plates or panels, and 3D printed standoffs, because it needs to be kind of thick to allow the motor to be fitted in there along with the slip ring. You have access to any of the stuff here with a nice big opening and another opening here for the gear. But yeah, it's kind of the gist of it. Try to keep it as simple as I could. I could have probably made the wires a little bit shorter, but I ran into some issues where I made them too short, and then I had to make them again, and then I made them too long. So it's kind of one of those things. And then the last thing I'll note is the DotStar LEDs. This is the highest density of pixels that we carry. It's 144 pixels per meter. I'm not sure the pitch of them, but they're the 50/50, I believe, size LEDs. And the way I adhered them to these 3D printed arms is with some Nitto tape that's typically used for securing material to like a CNC machine. It's this double-sided strong tape. It's called Nitto tape, which I have it linked in the guide. And you can still take it off if you like use alcohol. It'll come off easily. And I like that than using like super glue or hot glue, because hot glue can get a little bit messy. But double-sided tape is actually the right width of the pixel, so it ended up working really nice and seamless. You can't even see how I attached it. It just looks like it's built in there. So kind of cool. I like it. It's a fun project. First time doing a POV project with a motor. I have the brightness set really low, just because it's a pain to photograph when the brightness is full on. And it's a little difficult to catch it on camera, but you can kind of see it here in the webcam. So that's the gist of it. Any questions, let me know. Otherwise, we're going to jump right into the Learn Guide.
James is asking, he wants to check out the guide, but it's still in moderation.
Yep.
Should we just push it live or wait?
I think it's good to go. Why don't we just, as we walk through it, we'll publish the pages, because I have to painfully publish the pages. Okay. All right. So give me a second to make sure I don't run over any wires. All right. So you can see this, right? Yep. So this is a Learn Guide. I just published it, I think. Page status published. Yeah, I have to publish every page first. I really should have done this before the show, but hey, here we are. Here we go. Here we go. Thank you, Anne Barella and John Park, for proofreading the guide. It's just up to Lamar to publish it, but she kind of approved the circuit diagram already and the project, so it's just a matter of like publishing it. All right, it is published. You can check it out. Let's walk through it. The overview page has a breakdown of the project, all the things you need for it in the parts section. Everything is in stock. Look at that. Isn't that nice? Yeah, we have the slip ring in stock, which is great. That's the little thing that allows you to spin wires freely. You have the power supply for the motor FeatherWing. Some additional things like a little DC jack that just allows you to plug into the power supply easily. An inline power switch, so you can quickly turn off and on the 12-volt power. Some cables, the Pico 4-pin cables. You get some hardware. Now, the things that we don't stock are the hardware, like the steel balls. I got an assorted kit from Amazon. 5mm is the diameter of these steel balls. They're precision steel balls, which they're great for making custom ball bearings. Nitto tape is also on Amazon. And the last thing is the rubber feet at the bottom of the plate. So, a good assortment of things. It's quite a build because you still got to do a lot of wiring and finesse. Some finesse is required for, soldering wires to those fine-pitched solder pads on those DotStar LEDs. But here's the circuit diagram. You just have these two dev boards that attach the doubler, and then we're sharing the two data lines, the ground and the voltage of those two strips, which are DotStar strips. And then the motor just plugs into the M1 port of the motor FeatherWing. So pretty simple. The FeatherWing really makes it easy to connect motors and power them with all the power you need. You'll want to install CircuitPython onto your RP2040 if you haven't already. This page will walk you through it. And then the code page, let me see if I can do preview. This will allow me to see the code. Okay, so here's the code. Lamar put this together back in 2017. All I did was I added the motor code. So it just initializes the motor kit, which is an I2C connection for the motor, which is nice. And then the things you want to change is the file name of the bitmap, and then the pixel delay or the brightness. If you want to change those, the brightness just makes it brighter, and the pixel delay will either squish the image or stretch the image depending on how it shows up. Sometimes you want to adjust that number. If your image looks a little scaled or squished, you can decrease the number, or if it's too narrow, you can increase the number. That's pretty much all you really want to change. This is like version 1 of the project. We want to do a version next year where it has the ability to change the image on the fly and maybe do animated bitmap images. This was just like, let's do a minimum viable project. So here's all the assets. I have a few images here for folks to play with. Some holiday themed ones. I got a dreidel. I got, of course, Blinka, our CircuitPython mascot. I have Sans as a skull, some Xmas or Christmas ornaments, and a Christmas tree, and also the a themed background of the Super Mario Brothers, which is called Pipe Sky. So you can play with that. And here are the things you want to adjust. So pretty simple. Here are the CAD files. I managed to get 2 photos of the 3D printed parts because there are quite a bit of parts. So I think in total 14 parts. You'll want to print multiple copies of the standoffs, the LED arm, and the LED strip holder. So that's all listed there for you. The biggest part are the panels, the top and bottom panels, and they come out to 180 by 120 millimeters. So yeah, it almost takes up. There's still a lot of room on the bed actually, and then 50 millimeters on the Z, which is I think one of the mounts. I think the mount for the slip ring is the tallest thing. So really kind of short parts, really. And then if you want 3D models of the motor FeatherWing or the RP2040 feather, or even the feather doubler, we have 3D models in our GitHub repo, so folks can pick those up. This is the first 3D printing page with a bamboo screenshot. It's pretty funny. Onto the wiring assembly. I kind of broke out the assembly into 4 different pages. Wiring up the LEDs. You'll want to remove them from the silicone sheathing. That can be a little tricky. So you want to use some finesse, which I did here. You want to remove them from the silicone sheathing using a hobby knife and then scraping away the hot glue. It's kind of annoying, but that's how it's done. And then I'm using these cables here. You want to trim them out to be the right lengths. I came out with the right lengths after the build. So 2.5 inches, that's listed there. Soldering the cables to the DotStar strip is covered here. You want to create 2 of those. The DotStar strip actually comes in a 1/2 meter. Let's see if I can get that right here, actually, which is only $25, which is nice. You have just enough LEDs to create 2 strips with this 1/2 meter. So that's nice that we have them in 1/2 meter now because we didn't before. And then once you have that soldered up, you can reduce the length of the slip ring because they come pretty lengthy. You just want to cut these down to the 2.5 inches. And then we'll solder these matching 4-pin Pico blade cables to the slip ring wires. So we're doubling up here. So we're sharing, again, the power, the data, and the ground. This can be a little bit tricky. So I really recommend using helping hands. These are, oh boy, I forgot. Do you remember what the name of these are?
Oh, no. Omni something?
Yeah, OmniFlex. OmniFixo.
There you go.
OmniFixo helping hands. Why aren't we stocking these? These are so great. I love using them. It just made having 2 of them make it really easy to solder, matching wire, like multiple wires to 1 wire. And that's what we had to do here to split the power, the datas, and the ground connections. Obviously, when you have heat shrink tubing added before you solder, which I have here, you can see in the photos. And if you want to make the photos bigger, you can always click on them and see the full photo like that. So yeah, these OmniFixo arms make this type of solder work a breeze. Makes it manageable. I love them. Go ahead and check them out. That's my tip. So once we have those two 4-pin connectors, we can do the things like solder the headers to the doubler if they're not already soldered. And then we attach the bottom wires of the slip ring to the pins on the doubler. Now there's no pins. I mean, there's no labels on the bottom of the doubler, so you have to kind of reference another dev board like a Feather RP2040 to make sure that you are doing the right pins. It just works out better when your wires are like soldered underneath instead of on top, because then they kind of get in the way when you install the RP2040 Feather and the motor FeatherWing. So those are one of those things. That's why I label it advanced, because you kind of have to reference things and be, you know, a little tedious wire connections. Attaching the headers to the two dev boards is the next step. And then we can power test everything. So you want to plug in the feathers to the doubler, connect the strips to the slip ring, and give it some power. At this point, your CircuitPython and the code should be loaded on the Feather, so it should just kind of power up, and then the LEDs will start blinking. The last thing I want to do is set up some wires for the DC jack. It has a screw block terminal, so you just want to attach those to the negative and positive of those screw block terminals. That's pretty much the wiring, all on one page there. Next up is installing the bearings. This is a little tedious as well. Maybe I'll come up with a better solution in the future, but it's comprised of these 4 parts. 4 3D printed parts. You have like the outer bezel, the top and the bottom hub, and then the insert, which kind of just keeps the balls from like bundling up. It keeps them evenly spaced out, because that's how a real ball bearing works. It always has an insert. So you start off with fitting the bottom hub inside of the outer bezel, and then you'll want to install the insert with the thicker part going down first, face down. And then I made these GIFs here. These GIFs are really handy because you kind of have to slightly lift the outer bezel so that the balls can actually fit into the groove. There's a little groove on the inside of the bezel, and that allows the ball bearings to like be nestled into that. So you fit those, you pop those in one by one, because that's how it's done. And then you can just plop the top over and line up the mounting holes. The next thing you want to do, this is a little bit weird. You can't just lift it up, because if you lift the bezel up, all the steel balls are just going to fall out. So what I ended up doing is I kind of slide the whole assembly onto the edge of the table, just so that I can pinch the 2 top and bottom hubs together. And now I can flip it and get to the mounting holes. So I can install the hex nuts on the hexagon recesses and then add a screw. But what you want to do is you want to just kind of do 4 holes with 1 hole kind of empty. And that's just because like I needed a way to attach this assembly to the top panel, because that was just like the best way to do it. So I ended up like creating these 8 holes, but first you want to just use 4 of the holes so that they get secured together so the ball bearings won't fly out. But once that's assembled, this should be free spinning, and then you can add the helical bearing insert to the bottom of the bezel. So there are these little notches that you just line up, and just make sure that the helical herringbone shape of the teeth on the gear are oriented in the right way. Just reference the images, and that's pretty much it. Everything is really modular at this point. Like this whole ball bearing is like super modular. But at this point, it's all ready to go. Next up is installing the LED strip to the LED arms. There's a little hole here that allows the cable to pass through. And then you want to use the double-sided Nitto tape to attach the strip to the LED arm. They come out like that, do 2 of them. And then this like extension arm I wasn't sure exactly how far I wanted the LED strips to be apart from each other. So that's why I made this extra arm modular so that I could always change it and make it longer or shorter. I thought that was pretty clever. So there's just 4 mounting holes. You'll use the 2 of them to attach to the actual LED arm using nylon screws. The reason why I use nylon screws is because they weigh less than steel screws. And I found that the less weight you have when you're spinning this thing, the better. So you might as well use nylon screws. And they're black. They match the color scheme. So they kind of blend in. Anyway, you do that 2 times and you have these LED strips attached to the LED holder and their LED extender arm so that you can attach those to the ball bearing in the next step. So we'll start off with the bottom panel. I got these 3D printed M3 sized standoffs, and they actually work really well. So you just attach them. They kind of self tap, which is nice. And then we'll attach the slip ring mount to the center of the bottom panel using 4 M3 screws and hex nuts. They just line up nicely. It's kind of symmetrical. It doesn't matter what order you attach it to, or what orientation rather, as long as the standoffs are sticking up. And then we'll move on to the motor mount. The motor has to be orientated in this way. So just orient that. They're pretty long screws. Unfortunately, they have to like go through the whole body of the motor. So 24 millimeter long M3 screws. You'll definitely want to get some really long screws for this one, and then some hex nuts that are lock nuts. So they have that like nylon insert, so they lock into place and they won't fall out. They won't unscrew themselves when they're vibrating. So at that point, we can attach the motor mount to the bottom panel, because that seems to be where everything gets attached. And then once that is attached, make sure this is in the right order, of course, the right orientation. Then the DC jack gets attached. I came up with this little bracket to secure the DC mount. There isn't any mounting holes on the DC jack, so this actually ended up working really well. It's got a nice tight fit, and it just clamps to the center bottom of the panel, which is nice, because now you don't have this like dangling connector, which is nice. So that's a good little tip there. I like doing that. The slip ring just it has a flange, has a built-in flange, which is great. Some of them don't. This one does. It has 3 mounting holes, and you use M5 screws to attach it to the 3D printed mount. M5 screws. After that, the FeatherWing Doubler gets attached to the built-in standoffs. There's 4 of them. I only use 2 screws because I'm cheap. After that, we can install the Feather RP2040 onto the doubler. And then we'll connect the motor to the motor wing and the DC barrel jack wires to the power input of the motor wing with the screw block terminals. So that's easy. Now we can attach the ball bearing or bearing assembly to the top plate. There are these like little raised mounting holes, and that's what we'll use to attach the bearing to the top panel. And you'll notice that they're raised because like I needed some clearance between the gear and the plate. Otherwise, it'd be like it would be rubbing against each other. So I had to come up with these raised standoffs. They're kind of standoffs. And once that's attached, you can start threading the cables from the slip ring through the center of the top panel and through the bearing, and they just kind of come out like that. And then you can attach the top panel to those 4 standoffs that we 3D printed with some M3 screws. The last thing we want to do is attach our 2 LED arms to those kind of wings or mounting tabs of the ball bearing, because they're built into them. Again, with some nylon screws and some hex nuts. And now we can just plug in those LEDs. It feels so good to just plug in something and not have to solder something.
Mm-hmm.
So once that's good, it's easy to just plug that in, and it's modular. You can disconnect it and take it apart if you ever need to. All right. One of the last things to do is install the motor gear. The 3D printed gear has a fitting for the TT motor, the shaft of the motor. That just press fits. It has a nice snug fit. No need to secure it down because it has a nice press fit and it's friction. So you'll want to kind of adjust the gear on the LED arms so that they mesh together, because they tend to lock in really well, especially because it's a helical gear. Yeah, after that, you're pretty much ready to power it on. Keep your hands and fingers away from the LED strips while they're in motion. Yeah, that's it. Plug it in. Give it some 5-volt power for the feather, and power the motor FeatherWing with that external power supply. It's adjustable, so you can go to 6 volts is the recommended rating for the motor. But if you want to go faster, I guess you could go faster, but you just don't want to burn out the motor, so be careful. And yeah, that was kind of the quickest, most modular way to create this spinning LED strips that I could come up with. Like I said, this is version 1. I think next year we want to do a really nice one that has like a Hall effect sensor, so it knows when it's facing you and it knows how fast it's spinning. A little LED or OLED display where you can choose the image, and then maybe even animated bitmaps for version 2. But this was just a way to get like the mechanics sorted out. And is it even possible? Because went through a lot of prototyping with this one, starting off with 1 LED strip that was like not good. So then 2 worked out well, but then I couldn't get it spinning fast enough. So then I added 4 LED strips, and that was too much. It was drawing too much current, and it was becoming a lot. So I really reduced it down. It's like, what's the most simplest way I can create this POV effect with just 2 LED strips, the motor, the slip ring. This is what we got. So kind of fun. Yeah. Christmas tree. There we go.
Cool. Super cool, and on theme for the light up holiday.
Yeah, it's a lot different than like a tree, because it could be any image. It's got this kind of holographic kind of look. Yeah, one of Lamar's first projects was like a POV kit, person's vision kit. So it's kind of cool to like circle all the way back to Lamar's roots. And then like, how do we make a modern POV display that's motorized? So that's kind of cool. Yeah. Let's check in on Discord and see if there's any questions about it. Oh. Yeah, I like that thumbnail of the nail on cat. That came out to be the best picture. It was really hard to capture the image because it's like in motion, and like you need a good background. The lighting conditions matter. I tried with a flash, and that ended up working out well. And then capturing on video is even more difficult. So it's one of those things where it just looks so much better in real life.
Yeah. You did a slow shutter speed for this to get the...
Yeah, I ended up using a slow shutter speed. 1/10 of a second seemed to be okay. But then when you get too much, the image starts overlaying itself. Yeah. So because it's in motion, whenever we did a light painting project, you just do one pass. This is doing many passes. So you're kind of superimposing the image over and over again. So it was really difficult to get this image. Yeah. And then some of the colors don't turn out right sometimes. So it's a combination of your ISO, your f-stop, and of course your shutter speed to get this image. Yeah. Difficult to photograph.
Yes.
Because it affects that only works in your mind.
Yeah. Squid saying, yep, white balance issues for some reason. There is an option on the iPhone, I forget what the name of it is, under setting, so you can just maintain one white balance temperature while you're filming, so it doesn't flicker on you.
Yeah. But it is a magical effect in person when it's in motion and with dark lights. Because, yeah, I had to turn off all the lights when I got these photos. And some images look better than others. Of course, you want like a really good 32 by 32 crisp 8-bit style like image bitmap. Because when you scale an image down, it tends to like just become this blurry mess. So using a lot of like sprites that are already designed to be like an 8-bit image tends to work out the best. Blinko was kind of hard to photograph because like she doesn't scale well. Lamar wanted a dreidel, so I ended up getting this dreidel, which I think could be some of the colors could have been adjusted for this, but one that really came out great was the Sans skull. Like it comes out so crisp because just the contrast between the black LEDs, which means an off LED, and just full white ends up working really well. And just the way it was designed, it's like really crispy. Same thing with the Neon Cat. It's just a really crispy 8-bit image that works well.
Yeah, because each pixel is able to get addressed to that pixel.
Exactly, yeah. And there's, there's some space in between the LED, so you see that in the photo, but that's kind of the way it is. Yeah. Yeah.
So cool. And, yeah, the guide is now live. All of the parts are live.
Yeah, all the parts are in stock. Yeah. Yeah, I think this slip ring is such a useful thing, especially for like robotics. So let's say you're doing an R2-D2 and you want the head to keep spinning, and the R2-D2 head has LEDs, maybe a camera and all that stuff, and you can have it, and a speaker and all that stuff.
Smoke thing.
Servos. Yeah. So we have multiple ones. Our biggest one is the 12-wire one. Oh no, I don't see it. We have one of these with a flange that have 12 wires. I'm not sure why it's not showing up. Here it is. Yeah, we have these. These have 12 wires. So if you have a bunch of components that you want to be independent from your dev board and spinning, you'll want to use this one. I use the 6-wire one because I'm only doing 2 strips. So I actually only end up using 4 of those wires, and I just kind of clip off the remaining 2. But yeah, I like this one because it has, of course, the mounting holes and a flange. So it's nice. Originally, I was attaching the LED kind of hub to this rotating black slip ring piece thing, but that didn't end up working because it just didn't have enough surface area to like grab onto it. So I ended up just like not attaching anything to that and creating my own ball bearing. So that's why I created the ball bearing.
Yeah, I didn't realize that you actually made the ball, like
made the ball bearing
from making the balls or the steel balls that actually make the bearing.
Yeah, I felt the steel balls would work the best because they're perfectly smooth.
And you didn't have to use any oil for that, huh?
No oil, no, just free spinning. Yeah, a lot of people. There's a lot of ball bearing designs on like Thingiverse and beyond. That use the steel balls, and that's kind of what inspired it. Cause like, I'm surely people have done that. And I saw a YouTube short of a person who used really big steel balls and was able to make like a giant Lazy Susan where he could stand on it and spin on it on himself. And it's like, wow, these are really strong. So yeah, why not just make your own? Because they can get really expensive. I think it was $30 for the ball bearing that I wanted. That was the right diameter. I was like, I'm just gonna make it because the steel balls themselves is like $10 for a pack of 100, and I can make any size. Any size ball bearing I can create now. And we're about to stock a new stepper driver, and I want to make my own turntable. So now I can create a nice turntable with those balls and have them have the weight evenly distributed, or have a bunch of weight on it now, and not have to worry about it like flopping over and something, because you can't really use those tiny skate ball bearings because it's just too small. You're gonna have a lot of weight on the edges of it. So create your own Lazy Susan kind of thing.
Very cool.
Yeah. Cool. Learned a lot with this one. Getting better and better at spinning stuff and using motors.
Yeah, this is perfect for the R2-D2 one. With that separate motor coming in, I think finally finished that up yet. You have the whole design.
Yep. Good stuff.
Awesome.
All right.
Coupon code is, what's the coupon code?
DotStar.
There you go.
Not NeoPixels, DotStar. You want to do POV effects? You need really fast blinking lights, and the DotStar LEDs will do that for you. Yeah.
Oh yeah, before I forget, for Squid, it is under camera setting and then record video. Scroll all the way down to the bottom. It is lock white balance.
Oh, I need to do
that. Why do they hide that? Why isn't this like right in the front page?
Okay, so the settings app, camera, and then lock exposure.
The settings, yeah.
Nice. Good tip. I like photography tips.
All right, jumping into what are we prototyping?
Yes. What are you
This
prototyping?
week we are looking at what we're prototyping. Let me change cameras here to look at the Raspberry Pi Display V2. Lamar wanted a mount for this. Where am I? Oh no,
Wow.
doesn't fit.
Oh, you didn't take the protective layer off yet. I can see.
I know, because I know I'm gonna have to. I know I'm gonna have to keep touching it, so I'll take it off for now. Hopefully, I don't get it all scratched. But yeah, here is the Raspberry Pi Touch Display V2. I think it's high resolution, and I think it's a little thinner. So I was trying to check out different case designs for it, and I could not find one in what Lamar wanted, which was a wall-mounted one. So I wanted to make one where it is modular. So this pops right out, has like a little hinge on it. All 3D printed because we are going to send this off to JL PCB so we can get some parts to stock. So the kit that we're going to stock is going to be the case for that, a little hingey, and then pop that back into the thing here. A longer hinge so you can actually mount this to a wall. And that looks like this. Where's my video? There it is. So it just mounts to a wall, and the way that it mounts is there's these screw holes that you can use, or very happy to report that we're using the command strip, the little sticky tape, and that holds onto the wall a little too well. I had to rip off the or break off the printed arm for this, and I did have to apply some force. So luckily, it's not just going to fall off the wall. So it holds very, very well without having to use those screw mounts. But of course, if you want to bust out your stud finder and screw this into your wall, that should work perfect. And it's all print and play. So there's these little pins in there, 3mm diameter pins that have a nice grip on that. And the little bases fold all the way down, so you can adjust this to any almost any angle for mounting on that. And the Raspberry Pi 5, I forgot to mention that, it's the Pi 5 with the case that Lamar wanted or requested was Pi 5, the M2 kit, so you can have the SSD on there and a fan as well. So all that is housed.
Oh yes, the active cooling fan. So yeah, your enclosure will not melt. Yay! Yes. Mine melted last.
Yeah.
And I love how it slides out. That's great.
Yeah, it just slides in and out. And this little thing that it slides into, you can actually use the command strips on that so that you can have the arm attached to this, and then you can slide this in and out on the wall or put it back on your desk.
Yeah, I love the articulation on that. You can really swivel it out and put it in all sorts of different angles, which is cool.
Yeah, I took inspiration for this for the mounts that's on this TV here. So that's what usually is on the Vista mounts. It's just like 3 arms with a pin inside, and then the base that you screw that into the display.
So this thing prints like tall wise, like on the Z. It's not flat when you print.
Yeah, it prints just like that. Z.
I never would have thought that would work. I'm surprised.
Bamboo printer.
Yeah, how does that work?
Praises to the bamboo printer.
Overhang.
It's, excellent flow. Extrusion flow. Oh my god, what am I blinking out on it? What's the name?
What, like that active cooling fan?
No. The flow extrusion, not leveling, compensation. What is it? The calibration.
The calibration. Okay, yes.
Flow extrusion flow calibration is what's getting the super fine detail on this. And yeah, like you were saying, I did not think these little gaps on here. It's just 0.3 for the gap, and that still allows it to have very free motion without it fusing.
Yeah,
like on any of the Creality printers, this would not work.
Would not work.
Like, take a look at the gap that we have on here. It's 0.3. I sent this over to JL PCB, and they actually wanted a 0.6 gap on it. They were afraid that it would fuse. So wow, we're able to do resolution that's even higher than what the resin printers are getting. It might be just, them cautionarily telling us so it doesn't fuse. But man, isn't that cool that the based on the case that you sent off for the solar charger, the tolerance that we got off of that was perfect. Just what we're sending over to the for resin printing, we're able to get in the FDM printers now. Super cool. That means that we're going to cut down on prototyping when we're sending off prints. We'll know that our tolerances are going to be exactly what they're getting out. So for stocking, that should decrease the time in terms of getting prototypes and getting the tolerances to fit perfectly. So the 0.6 millimeter gap, that's what that looks like, and that still works really good. So hopefully, I just got the email now from them, from JLPCB. So
cool.
Hopefully we can get some prototypes. We are going to get the white resin that we've been getting the cases in, as well as the black resin to sort of match the bezel of the display. So we have cutouts for the USB and all the ports on there, as well as down here the have the 2 HDMI ports, and of course the USB-C for powering. And then what side do I have it? If you could reach it, the SD card, and then the little hole for the reset button back there. Of course, the grill for the fan. All those port openings and cooling. There's is frame that is fused to the main case here, and then the lid on top screws in with M25 screws.
Okay,
that's how that is all screwed in there.
I like the screws because if you do snaps, you're just gonna get. It seems like it's going to be a lot of weight. And
it is.
Snapping.
I was scared that the command strips would not fit. I'm like thinking for hero shots. I'm like, oh man, I don't want to drill into the wall just to get the hero shots for that. So super happy the command strips work for that. And then the stand.
It's a nice stand.
Yeah, this just finished printing. I think it prints like in all this stuff prints in like 40 to 1 hour.
That's incredible. Yeah.
We're printing at what is the default 230 millimeters a second. Like this would take 4 to 6 hours on the printer. So we're able to, reiterate. I think this is like the 4th version of this. I would have been still like stuck on the 2nd version and not realize that, oh no, my SD card isn't aligned, or the grill. Oh my God, look at the quality of that. Like I would have had to go in there with the X-Acto knife and cut out all of the string hairs that we usually have for those types of venting grill designs on the Creality printer. So super high quality, and this is 0.24 millimeter layer height, but it looks like it's freaking 0.2 or even 0.15. And again, these print so fast. The if I can remember the word again, extrusion
calibration.
Yes, extrusion flow calibration is what is making these parts come out so freaking clean and so leveled.
So consistent. The quality is just so consistent.
Yes. Yeah. Oh my God, consistency of it.
Yeah.
So yeah, the little base adapter that screws into the stand, so this can be used on the wall, or you can get 2 of these and then have one on the base, one on the wall if you're gonna switch this around. And then the base should be good enough to not fall over.
It looks good. Yeah,
I think
it's pretty balanced.
I think I made it long enough to where it can absorb the heaviness of this. I didn't weigh it, but I think the weight limit for the command strips, I think the ones we have is like 12 pounds. So
12 pounds. I have the same. Yep.
I did make this wide enough so you could add 2 command strips. Just to be extra careful, but man, 1 is plenty. Like I was saying,
okay, good.
Maybe it's just the tile that that is on the kitchen. Maybe it's because of that it was able to get such a
drywall paint.
The suction that it had on it was too good. Had trouble removing it. Like when I went over to how you just pull it downwards. It maybe just because of the way that I was pulling it off, it ripped right off. So I had trouble. I had to get a one of the spudgers to get the sticky stuff off of there. But it works really good. If you're like getting cooking tutorials or something is what I'm envisioning, like for the kitchen or something like that.
Yeah.
Have that extra little display on there. If you don't want to have like a spare iPad, you can have a spare display on there. The USB-C power, it's perfect for mounting it right where your outlet is.
Yeah. Yes, this is really useful for that. And if folks use Home Assistant, they have like a nice little controller for that. Adafruit.io projects that you show on your dashboard works really well.
Yeah, it is a touch screen, so you can control everything through the virtual keyboard. Virtual keyboard that pops
that's nice and big.
Yeah, they did a really good job on that.
Nice. Yeah, I need to get set mine up.
We got keyboard settings.
Now that my printer's free, I can like start printing it. I got my kit here.
It takes about 40 minutes.
Yeah,
so it's nice and fast.
Mine. I gotta put it together.
Oh yeah. The parts are good to go. I can. We have the same printer, so I'm not worried about tolerances. Usually it's like, oh no, it's different. Nope, it should be the exact same. I see every single Instagram post or printing thing on social, they're all using bamboo. So super happy to know that it should fit everybody's build plate and the tolerance should all match up. Nice. Let's see what else can I say about this. I mean, maybe some grippy feet on the bottom.
Sure, yeah, that's easy to add.
What else? Yeah, JLC just sent the thing for approval, so I'll go ahead and order some of the resin prototypes for that, and we will have those stocked in. I don't know, maybe like a month or something, but the project will try to release this for next week since it's ready to go. Just got to get hero shots of it in use in the assembly. We can post the parts if you just want to print this out.
Very nice.
There we go.
Yeah.
Super cool.
Got a question. Duester, how about the CM5 IO board case? We don't have it in stock yet. We only have the 4 IO board.
Okay.
Yeah, so I didn't have the 5 yet. Like, if we can get our hands on one, of course, we'll make one. It doesn't make sense to make something for something we don't have yet. So
yeah,
I haven't really used any of these before. I thought these were for like industrial uses and stuff.
Yeah, for the stuff I usually see like DIN mount for the rail.
I guess this makes it slimmer. Seems like it's longer. I'm not sure. I have never used a compute module from Raspberry Pi.
It's supposed to be more for like embedded type.
So yeah. But yeah, maybe. Again, this was like a Lamar. Hey, why don't you do this? Like,
Yep. Like we were saying before, when I'm looking for cases for like design inspiration for this, I did not see any that were wall mounted or that had the swiveling hinges or even like a stand like this. I already closed the window, but it looked not like this. Not simple, like almost like an iMac or something.
Yeah. What's it
called? And of course the modularity of being able to just pop that out. I should probably add some way to so the cable don't have to thread it through like right now. I'd have to turn it off, pop out the USB-C cable, and to be able to freely take this out. But quite happy with the little swiveling on it. Even though you could just kind of turn this around, but if you're limited on desk space, you could still.
Right. It's definitely enough. Yeah.
Cool. I did try having this this mounted onto the desk stand, but of course the weight of it is too front facing or too much forward weight in that, and it would topple over. So I don't believe this would work, but I did increase the base of that. So I don't know, maybe that would work. All the same size, but I don't know. Maybe I'll try it out again. So I did increase the bottom here, so there wouldn't be too much weight in the front. Other than that, the Pi 5 is super speedy. Like the startup time is it starts up way faster than I think the 3 or the 4 does. And then added what is it, the NVMe SSD hat that is on there as well. The latest version, it does show up as a in the Pi Imager app on the Pi OS does show up. So I should try making an image for the Pi on there so I could boot off of that SSD drive and boot up even faster.
Very nice. Okay. Out next week.
Yes.
And create all
sorts. In terms of any other additional stuff, there is like a stemma connector on the Pi 5, isn't there? For like,
I don't think so. No.
What is the port that's on
it's
here?
Not. It's definitely not.
Okay.
See, yeah. Anything that we think
stemma
never is.
Yeah.
Yeah.
I was gonna say like, I don't know, have like some sort of connections up here for like sensors or something, but yeah.
Yep.
I already showed Lamar if she thought that was a good idea, she would have said so.
Right. Yep.
I think that's the only additional things, like mounts for sensors to plug into that UART connector. It'd be pretty cool.
Yeah. All right.
But I guess you could use the vent. I don't know. Or I don't know. It'd probably block the airflow.
Yeah. I think just keeping it simple is what you wanted.
Yep. That should be good to go.
Cool.
And we'll try to release this next week. And I think that'll wrap up the year for the projects.
Yeah. All right.
Nice Pi 5 project.
We're gonna go overtime. I got too much stuff to cover.
Oh, okay.
Let's see, just a quick update. So we have this. It's hopefully going to be in store. Sorry about the camera. It's just not good. Nope. Yeah. This is a very bad camera. I need to get a better one, huh? I would use my phone, but like, sorry, folks. This is a USB solar charger case. It's just 2 pieces here. Hopefully we get this in stock today or next week. I'm doing a whole slew of them. This is the similar chipset, the BQ2185, but with wow, this is a very terrible camera. This one has the 3-volt buck. It's really simple. It's got screw block terminals here. It has labels for the different voltages. It's hard to get good lighting on this camera or even focus, but it has the screw block terminals for your solar panel, a battery, and of course USB-C. It's just a two-piece case, and then it has these M25 mounting tabs. So that has been on order. And then I need to make a case for this version, which is the 5-volt variant with the 5-volt buck converter. We have like so many of these USB. So Lamar wanted cases for all 3 of these. So that's pretty much it. Not much to talk about other than we're using JLC PCB to create these parts for us so that we can stock them in the store. They only come in one color, but it's a nice color. It's white. It allows the LEDs to shine through. So that's what I'm prototyping. No new projects yet. But kind of a shop talk thing. I want to give a huge shout out to John Gallagher. He hosted a event on last Friday. It was the Student Technology Showcase. So he has a class where he shows students how to build iPhone apps and CircuitPython projects. It was really cool to see all the students' CircuitPython projects and them talking about it with such glee. So here's just like the second makerspaces they have, where they have like really nice facilities. So many bamboo 3D printers, soldering stations, photo booths, tools, hand tools, CNCs, lathes, you name it. They have such a great facility. Lovely desks.
Wow.
Perfect lighting and flooring, and it's just cool. Really great. Me and Liz attended. There's this in front of the classroom. Here's just they even have like a Stratasys printer, which costs a lot of money. Oh, wow. DLP printers as well. They call it the Digital Fabrication Shop, which is great. Nice. Here are a couple projects from the people. Hey. Elise had this really cool 3D printed case of a frog using soil sensor. So did a soil sensing project. That was really cool. Whoa, I'm spinning too fast.
Oh, they got some Hoyas.
Yeah, right. You know exactly what plants they are. So that was really cool to see and then talk about.
They had mapias.
Yeah. This was a cool one. It's kind of like an alarm where it has like a toothbrush and you'd have to lift the toothbrush to turn off the alarm. They had a musical project here. which is like it's like a it's a an iPhone app that kind of brings different instruments together, which is cool. All done in CircuitPython.
I like the little printout.
Yeah, right. They did a lot of 3D printing. And then we have, I think this was like this was a cool way to kind of show how to do a sign language. So they had this mechanical arm. You would type in something on the Raspberry Pi, and then it would give you the hands. Okay. I only got a photo of it, but yeah, Luke put that one together, which is really cool. Wow. Next one, this was a kind of a cool timer project using the Matrix Pi portal, or the portal Matrix portal, I believe it's called. This was by Leonard and Gabriel. They did this fun kind of timer where as the timer increases, the image gets built up more and more, which I thought was a clever idea. Nice. They had some infinity mirror projects. They had a smart lamp and other fun.
Yeah, I like the shake to wake.
Yeah, that's pretty cool. Here's like a little. Yeah.
Huh.
Yeah, and then this box kind of helps you kind of with some braille kind of stuff. Some accessibility projects is cool. A little golf game, which is kind of neat. You use there are two BLE circuit playground blue fruits that you can control the servo with the other as you rotate it. So really cool projects. Shout out to John Gallagher for inviting us. Also met Guy DuPont was there. That was cool. So we got to meet up. Yeah, all good stuff. Cool. Yeah, I hope to go back there, maybe use some of their facilities. He said in exchange for like a layer by layer or something. So that'd be kind of cool to give a layer by layer on 3D printing some enclosures for folks that are just learning all the stuff. Let's see, what other thing that I want to cover? Let me check out all my tabs here. Go ahead and answer any comments on the chats if you want, as I get my screen back together here.
Let's see.
It is this one. Here we go.
Just some chatter about the CM5 IO board that DotStar is testing out.
Okay. What about it? Let's see.
He said it's running circles around other Pis.
Oh, interesting. Yeah, let's maybe we'll stock it. Maybe it's on order. I'm not sure.
Then Joe saying about if the LED strips were mounted at an angle, you can apparently get a higher density if they were angled.
That's interesting. Okay.
So.
All right, good stuff. All right. We're really over time here. I guess I spent too much time talking about the POV display or something.
Yeah, it was a pretty intricate build.
That, and I think yours was too, yeah. So you almost kind of covered the whole project.
Yeah, so this week's Time-lapse Tuesday for Community Makes is this multicolor little articulated snowman. It's like it's using a little chain design to attach all of the different pieces together. I did go ahead and do the flush to object, and I decreased the the index flush or extrusion rate flush thing. I lowered it to 0.5, and then I decreased the purge tower, like the 10 by 12, and then I printed two of them at the same time, as you can see in the time lapse. And then you can see where it's flushing some of, like, say, the black material into the fill, and have less waste for the purging or the color changing, and it came out pretty good. I mean, you can barely tell. I mean, you can see the black, but you probably didn't notice until I mentioned.
No, I didn't notice until you brought it up. That was just like a shadow of your hand or something.
Right, yeah, it looks like shadow from his little arm. But nope, that's flushing into the infill, and then lowering the index for the color change, lowering the purge block to have less waste. I probably should have had colored this like white to like the little hoodie and the little puffy ball. But yeah, you can see minimal bleeding, like the white and red where his buttons are. But yeah, I'll take it to save on the purging and the waste for the color changing. Like I was saying, you can see back here the way that they're doing the Flexi part of it looks like it's the chain design for it.
Mm-hmm.
See on the inside there.
Yeah, it has a cool effect when you pick it up. It's kind of like it's about to come together, but then it catches itself.
Yeah, sort of like how Olaf jumps around.
Yeah, it is.
Like
his
each individual
catch a little bit.
Yeah.
As he's like kind of moving around. It's pretty cool. I like it. So this is on Thingiverse. Oh, Thingiverse. Still got Thingiverse. I'm not sure if this is a render or is this a real 3D print. Designed by Zen Engel 99.
I think the last photo though was a print. Oh wait, no, it's not.
Yeah, I don't think this was printed. Hard to tell, right?
I think it's a render.
Pretty sure it's a render, yeah. So anyway, you found it. It says there's a keychain available on Patreon. Keep in mind.
Oh, is that what you're laughing at? The ads for it.
What ads?
No, it's gone now.
Oh no,
the little banner that it was showing.
Oh, okay. Yeah, there's a lot of ads on Thingiverse, guys. Sorry. Yeah, not much about the model itself.
No makes too, huh?
No makes. This was a risky.
I need to post it as a make.
This is a risky thing to print, in my opinion, because it's like haven't actually printed it, but there is a 3MF file and it's free, and you can download it and see if it slices. You didn't have any issues with it?
What I was impressed with was in Bamboo Studio, I'm using the paint bucket tool to paint in each section for all the different colors. Even the eye and the nose came in pretty dang good, huh? Like,
yeah,
you can see how sharp the change is for each triangle for the mesh. So I was super impressed with that.
Yeah, me too.
The way that it colors in.
Yeah. The texture is like this kind of knitted texture.
Yeah. Cool. You can see it there.
Yeah, it gives so much like.
It does. It's like that fuzzy effect. I like the knitted effect on it.
Yeah. I've been seeing that a lot lately. A lot of knitted.
It looks
textures.
So good.
I think it's like.
I had the kids fighting over it, and it's like, I printed 2. Thank God.
Yeah, right. That's fun. So it's a free download. Folks want to try it out on their printer, and then you can, like you said, paint it yourself.
You gotta digitally paint it for each extruder.
Right.
Make sure I clarify. This is why I got it, so I don't have to sit there and paintbrush and do the little washy thing, thingy brush thingy, whatever.
Yep.
And then follow all the purging, color changing tips for decreasing the waste filament that you get for all of the color change.
Very cool.
I would print a brim on it. The second version, the flushing version, or the flushing object that I used, the head did pop off the plate, so I was scared this one was gonna fail. Because as it's printing, and you can kind of see it in the time lapse, the snowman in the back, he's jiggling back and forth as it's printing. Yeah, in the back there, the face you can see.
You can see it. Yeah,
it popped off the plate. So I would add a brim to it.
Yeah.
Just in case, because I thought this was gonna fail.
Yeah. Interesting.
And it's quite a balancing act to get them to stand up.
Yeah, because it's so smooth at the bottom.
Yeah, there's no flat part in the bottom. The flat part is on the back.
Yeah, I think you can cut faces in Bamboo Studio.
Yes, you can. It is.
Do that if you like.
It has the same UI as a Prusa slicer. So all that same ability to cut
tools.
Yeah.
Very cool.
The one thing I have seen, the reload STL from file or from disk does not work. So I have to delete.
Stuff. It did for me.
You know what? I thought it did too. Then I printed out like 2 of these, and I was like, "This is the old design. What's going on?" And I noticed that it was not reloading from disk.
Must have been something. Yeah, I used it 3 times.
I could have sworn it did.
Where I kept updating it, and I would look at it too carefully. I'd be like, "Okay, is it going to change?" And it would.
I'm inspecting like.
So just be curious. Yeah, just be.
Maybe it's Dropbox. You know how every time.
They do the Dropbox. That's true. Yeah. Could
be that
Dropbox
messing with the
caching the yeah.
Even when I went into the window to load an object, I could see it was in the date created under that column section for it. It was for like the day before. So I'm like, oh, what the heck? The freaking file explorer isn't updating.
Yeah, a lot of the times in Fusion, when I'm exporting in an STL, I'll forget to update the destination that it's saving in. So I'll have 2 different projects open, and I always forget to save it. So I've done that before, and it's bitten me as well. But our printers are so fast that you can't.
They're fast enough that's why I didn't notice.
So much time. Yeah, great. Yeah, that's gonna do it for the show. We went a little over, because we got so much to cover, but it's good because next week we'll probably talk about the same stuff. I think.
Yeah, I mean, it's just gonna be the display, just assembly of it, I guess. Yeah, we will be off.
Yeah, so we're going to be here next week, but then we're off the week after. So we'll be off the 25th. We'll be off the 1st, and we'll be back on the 8th of January. We'll put up blog posts so folks know. But yeah, we'll be here on the 18th, which is next Wednesday, with another coupon code and Pedro's project and maybe some new projects that I'll cook up.
We have a whole list of projects.
Yeah.
I cannot remember what they are right now.
Yep, too many.
Kids always ask me, "What are you working on next?" I'm like, "I have a list. I don't remember what it is."
Yeah, that's why we have a list.
They want a Sonic project because of the Sonic movie, so it's like, I don't know what. We can't make a gun. Sorry, kids.
No guns.
We can't make Shadow's gun, so that's off. I don't know what other iconic Sonic things. You already made like the Emerald. So I don't know what else that we can print.
Okay. All right.
And some continued chatter on. Oh,
yeah.
Running.
People are sharing their experiences with their Pi 4.
Yeah, definitely join Discord.
Discord
Over at discord.gg/Adafruit to continue the chat. It is going on in the live broadcasting chat.
Yep.
Everybody talking about their benchmarks for the Pi 5. Yeah, this Pi 5 is freaking awesome.
Yeah.
You finally load stuff like a freaking computer, man.
It's fun to cut up.
It's freaking awesome. Like YouTube loads up. Like, as you've seen, I just was playing my videos. Oh, that is the only thing missing from a setup like this. Speakers. And I don't know if Lamar wants that. Yeah, audio output. I don't know if.
How would you do that? Yeah. I2S amp? No.
The Braincraft hat, but then you can't fit the M25 hat on there, right? The SSD and then the.
It gets
the fan fits
so quick. I guess that's why folks are like, hey, use the compute module. Maybe I don't know.
Yeah, that would increase. I would have to change the case around to add speakers. Oh, maybe just Bluetooth speakers. Would that work? I don't know if they support Bluetooth audio out.
Hopefully.
Add device. Let me see. There's Bluetooth there. Does anybody know? Searching for Bluetooth devices.
Yeah, can you do Bluetooth audio out of the Pi 5?
Audio?
I hope so.
Does anybody know?
Yeah.
I could see it right here in the menu, searching for Bluetooth devices, but I don't have a speaker.
Oh, USB audio. So you could always do USB speakers.
Oh, okay.
Or, Bluetooth would work. Yeah, Fuzzy Bear says Bluetooth would work. If you just had a Bluetooth speaker, yeah.
Yeah, I have one around, just not where I can quickly grab it now for the...
Yeah, confirmed.
Okay, yeah. Woo! All right.
Yeah, just do Bluetooth speakers.
Okay,
they're very affordable.
There you go. We have the ones that have like the suction cup on it.
Oh yeah, those are great. Yeah.
Yeah. So I guess that there we go. There's a solution.
They have Bluetooth speakers like at the $5 bin. Like
yeah, that's the exact one I'm talking about.
Department stores. Yeah.
Remember the little Boba Fett one that we have?
Oh yeah, those are cute. Yeah. It's still raining out there.
Like it's about to start storming here. The cold front has shown up. What was I saying? It was like 50 in the morning. Now it's 80, and it's about to be 30 degrees now.
All right. Well, later tonight we got show and tell, back-to-back shows, show and tell, and Ask an Engineer. The return of Mr. and Mrs. Lady Ada. They'll be back tonight, starting at 7:30 p.m. is show and tell. I think I'll be on there showing my thing off, and then Ask an Engineer is at 8 p.m. Eastern time. You can come on by the Discord server to get invited shortly before the show and tell at 7:30, and then hopefully we'll see some more of you tonight. JP's workshop is tomorrow at 4 p.m. Eastern time. A deep dive with Tim, Foamy Guy, because Scott will be traveling. So Tim will be doing the deep dive on Friday at 5 p.m. Eastern or 2 p.m. Pacific. Lady Ada is gonna, I think she'll do one this week. It's normally on Sundays. So that's cool. And then JP's product picks on Tuesdays. We can get up to 50% off select items. Yeah, I think next week we're going to do all the standard shows, but then slowly we'll be taking time off for the holiday and the new year.
Yay.
All right, everybody, thank you so much for hanging out with us and chatting and being involved. Good luck with everyone's maker endeavors and beyond. Stay safe out there, folks. We'll see you next week. But until then, remember to make a great day.
Bye, folks.